Hello, welcome to CA 675 assignment 2 on creating a web application. We have done our web application on recommendation engine. Recommendation engines are turned out to be a business in a current OTT platform, and today many of the OTT platform are using the recommendation engine in their own way, which recommend movies or shows to their respective users. So there are basically two types of recommendation engine. One is content-based and collaborative filtering. Content-based filtering method are based on a description of the item and the profile of the user preference, and meanwhile, collaborative filtering is based on the assumption that people might agree in the past who will agree in the future also. So here in this project, our aim is to create a web application for content-based recommendation engine based on publicly available data which contains 500,000 different movies. In this project, we will aim to clean the data set using Apache Pig, and application will be built using Flask and by hosting it in Heroku platform as a service cloud platform. Initially, what we did is we created a master node and a two worker node in GCP, which is an easier way to use a cloud service for running onto an Hadoop platform. We did our ETL process using Pig and Hive. The dataset was in 4 different CSV files. So what we initially did is we combined all 4 CSV files into a single file. Then we started our ETL process by cleaning the special characters in the genre column so that the columns are clean. There are total 26 columns are there in the dataset, and we don't want all column to recommend a content-based recommendation engine or to visualize the data. So we considered only a title, word count, genre, user table, and rating table, and the remaining columns are unconsidered. And later on, the CSV files are loaded and stored in HDFS. The whole extract, load, and transfer files are done using Apache Pig. And later on, we fetch through the Hive queries, and we build the sample queries in SQL, and the output of this were used in our Tableau desktop for the visualization. To build the model, what we did is we used the Flask to build the model for the content-based recommendation engine using a cosine similarity. And then once it is built the model, we dumped all our files into our GitHub. There you can see our GitHub is linked to the Heroku application, and we have deployed our application in in Heroku Cloud Platform, and build is succeeded and it is deployed. And if we click on Open App, it will redirect it to our Heroku path where our web application is hosted. This is our web application. So here, if we enter any movie like Avatar, so then if we submit, it will show the similar movie details which is recommended based on vote count and genre and based on the user selection. And there is an icon, if you can see over here, it will recommend which are the best movies with respect to the votes and everything. We have included a button called Go to Dashboard, which will direct to our Tableau. We actually tried to dump the Tableau onto the cloud platform, both in GCP and Heroku, but unfortunately that wasn't supported. So what we did is we basically redirected to our Tableau public so that anyone can view this visualization. So once we click on the Go to Dashboard button, it will redirect to our Tableau public desktop. So there, what we did is initially we had around 100,000 movie ratings for 1,000 users on 1,700 movies. So what we did is whatever the query we did it in Hive, we did the same process in the Tableau desktop for the rating table and the user table to check upon the top user ID with this movie rating and movie ID, and then to explore the data, which we did it in Hive query based on gender and age group. And we hovered it for the top 10 rated movies, which includes both the genre and all of the age group. And we also plotted a bar graph including all the genre, like how many movies are there based on the count and average rating. If you over to the all of the genre, we will get to know everything. And then to build, and our main thing was the content-based filtering. So how we calculated is we build our model using linear regression with the cost function by including the cost function. And there were independent variables in the movie genre. That is, all are independent. Nothing was interdependent. So based on that, we calculated the optimization and prediction and user preference. If you look at the optimization, the cross validation has come to less. With respect to error rate and regularization parameter. And if you see the training and cross validation, what we have done in this optimization, then later on in the actual, then the prediction we did based on the actual rating and the predicted rating, so that the user will be recommended with the based on his or her preference. So if you look into that, there are different actual rating and predicted rating. There is a difference in the particular movies. So then what we did is we checked the value of it by seeing into it different genre. So if you look into that, these are the negative value what we have got. But few of them they have recommended animation, comedy, romance, drama in such documentary sci-fi in such genre. So this is basically what we did. This is how we calculated the content-based filtering based on the cosine similarity function. And we also tried with k nearest neighbor technique also to in order to find in order to give a recommendation. But based on our analysis, what we did it on the cost function was pretty much well when compared to k nearest neighbor. And yeah, this is our web application which created the content-based recommendation engine for based on user.